Okay, so take this first quiz problem. I'm going to graph this function, right? Now we identify that this has the form a g of x minus h plus k, where g of x equals x squared. Okay? We spent a lot of time understanding why this is. If you substitute x minus h for x, you're going to get x minus h squared. You're going to have number a in front and number k right at the end. Okay, for this function, you probably shouldn't have written that in person, should I? Okay, for this function, f of x, well, f of x is in this form for this. If we write this out for the x squared function, g of x minus h is x minus h squared. The a is out in front of that and the k is added on to it. And that's straightforward function notation. So we have to practice function notation if we're not clear on this. Okay. So this function, we have this, so a is 1, h is -3, k is 4. Well, vertex is at the point hk, always. When we did this and developed it in class, the red dot is always our origin, or the point to which our origin is translated, okay? And for a quadratic function, the red dot is at the origin. We need to understand all that to get real proficient with this. However, what it comes down to is if the vertex is at hk, h is -3, k is 4. So first place, our vertex will be at h. It'll be at x equals -3, and it will be at y equals 4. And here's our vertex. HK is 3, 4. Okay. Now, what else can we say about this function? Well, the way this function is constructed, a is positive, so the parabola is going to open upward. So what we probably ought to do is find the y-intercept. If we have no zeros, if no x-intercept, since the parabola, since it's a vertex, goes above the x-axis, And the parabola opens upward. So it can't cross the x-axis, so no x-intercepts. So we find the y-intercept. No. Y-intercept occurs when x equals 0. So y equals zero plus 3 squared plus 4, which is 13. Okay, well, this is -3, and this is y equals 4. So you got to come all the way up to y equals 13 before we can locate vertex. There's 4, 8, 12, 13 is going to be way up here somewhere. So we extend our y-axis up this high, and we get a y-intercept. And now we can do a pretty good job of seeing where the graph is. It's going to go through here, it's going to come down here, and it's going to go back up. It's going to be symmetric about this axis of symmetry. So that's how we could graph this function. Now, when you wrote this out for homework, most of you followed the format that gave you an open math, and that's a good format. But I didn't see the connection between the numbers you put down and the form of the function. And this form is essential for applying the transformations. And, you know, when I set the camera up, I did everything but what I needed to do. So we couldn't necessarily see everything that I wrote, although up to the point where I drew the parabola, we saw most of what was important, but I did label the vertex here. So I suggest that you use this kind of format, combine it with the kind of format you see from Open Math, so that you can not only get the graph in the right place on the screen, but construct the thing by hand, labeling all your lines, okay? It's really the way, I think, and there are other ways, I'm sure, but it's a way that'll connect everything in such a way that we can come into class and answer these sorts of questions. Okay, and that's intercepts, that interrupts. Okay, so we're going to graph y equals p of x equals x squared minus 9. Using the intercepts. Okay. Write this out. It keeps urging people to write out the y-intercept when x equals 0, because people never seem to remember that. Open Math doesn't seem to really get that across. And Open Math is limited to the computer. So I think it's just a flaw, not a flaw, it's just a limitation of the medium. Okay, so I urge you do this. Write this out. Okay, y-intercept of x equals 0, so y equals g of 0 equals 0 squared minus 9, which is -9. Which means that the y-intercept is at the point 0, -9. So let's start a graph over here. I also urge you to draw these lines, because on a test, I'm not going to give you the nice square grid that Open Math always puts on the screen. You have to construct your own. Now, this doesn't necessarily apply to people who are in this course who aren't in my section. You're not necessarily going to have to do this. I still think it's a good idea, but of course, if you're not going to be graded on it and you choose not to do it, that's fine. I still recommend it because you understand it better if you do this, I think. Kind of depends on you. Okay, well, anyhow, the x-intercept happens when y equals 0. So we're going to replace x by 0 and find, sorry, we're going to replace y by 0 and find out what x is. Well, we easily solve this equation. I'll write x squared minus 9 equals 0. Just put the x on the left-hand side. But add 9 to both sides. So the solution, x squared is 9. Actually, there are two solutions. X is plus or minus square root of 9. Which is plus or minus 3. So x-intercepts at -3, 0, and 3, 0. I'm going to write x equals -3 here. Now I'm going to write x equals 3 here. Now my y-intercept is at 0, -9. Here's my -9 line, y equals -9. And I'm going to put a point here. And then the x-intercepts are at -3, 0, and 3, 0. Well, that's going to be here and here. And now we can sketch the graph. A little lopsided at the origin or the vertex, but there it is. Now this could have been graphed by transformations. V of x is a times x minus h quantity squared plus k. A equals 1. H is 0 because we don't have anything along with x to square. It's just plain old x squared. And k equals -9. This means we take our y equals x squared function, which would look something like this. Y equals x equals x squared. We take the vertex and we simply move it down 9 units. Each point moves vertically. K equals -9 units. So that's kind of indicated by what happens to the red dot vertex. But every other point moves along with it. And there's our transformation. Okay. Now we go to the third question. And we want to give the factor form of the function that I've sketched over here, and I'll resketch it quickly using its graph. And this function is sketched. Using x equals 4 here. Y equals -8 here. And x equals -9 over here. So we have intercepts here, here, and here. And then the graph it looks something like this. So here is the graph of f of x. Which is ax squared plus bx plus c. I'm trying to decide what symbol is going to be most useful for you. I'm going to use u. Say f of x is a times x plus u times x plus b. If you have a function for this form, then it's going to be 0 if this is 0 or if this is 0. It's got to be at x equals -u or x equals -b. Well, that's kind of a formal way of stating something that should be obvious. According to the graph, We get 0 if x is -9 or x equals 4. So f of x has to equal a times x minus -9 times x minus 4, which is just a times x plus 9 times x minus 4. Okay. Now, if we look at this, if x equals -9, is this going to be 0? So really, here's kind of how we look at it. We just verify. Be -9 minus 4. If x is -9, well, you just look at this and say, well, x plus 9, if x is -9, this is going to be 0. It's going to make the whole thing 0, but we can write it out. Okay, so we verified that this form has zeros here and here. Then if x equals that y, I'm looking at the graph, y equals -8, and x equals 0. That's the first thing my eye caught, and that's what I wrote down. Okay, y is -8 and x is 0. Don't do like I can, be careful. So what? Well, this y equals a times x plus 9 times x minus 4. This tells us we get -8 and 0. We get -8 equals a times 0 plus 9 times 0 minus 4. So that means -8 is a times -36. You would write that as -36a. And a equals then -8 over -36, which reduces to 2 over 9. since y was a times x plus 9 times x minus 4, and we found that a is 2/9. We just take this form here and combine it with the fact that a equals 2/9. And there's our function. So the bottom line is, whether we understand every detail of this or not, it's good to understand every detail. We could just look at our 2x intercepts and we can write this down. Y equals a times x minus -9 times x minus 4. So we don't really need all this reasoning, although it's good to understand it because it'll be useful. We can simply write this down. And it helps to verify it because we did this so we can see for sure that this does give us y equals 0 for x equals both of these numbers. And then we just use the fact that y is -8 and x equals 0, plug it in to this form and solve for a, and then write this in terms of a. Okay, now I just loosened up my shoulder pretty good because it's just kind of tight. Stood about 10, 12 feet away from the trash can. And tossed the chalk and it went in right where I said it would. Okay, there's an obstacle there. Now that's unusual. Usually I miss. But since I hit it, that means I calculated everything correctly. Okay. Well, you might or might not believe that I calculated it correctly, but I decided that the height of that piece of chalk as a function of position would be a parabola. Let me just draw the parabola here. Okay, so here's where I released it, and here's where it went into the trash. And this is going to be a parabola. It couldn't go up any higher than the ceiling, so I had it here and I have the ceiling constraining me. And I was actually a little closer to the ceiling than that when I released it. So the thing, I wanted the maximum possible arcs. I arced it up so we're pretty close to the ceiling and then come down. And that's bad, but that should be a parabola. So that if I graphed a y versus x, my y-axis here and my x-axis here, I started at the point, let's say 12, so I released it at about 5.5 feet, but let's say loose at 5 feet. So standing in a hole. Okay. And I hit the trash can. When I went into the trash can 12 feet away, at a height of 2 feet, let's say. It's like some sort of parabolic path from here to here. Now I can't figure out why the camera went out of focus, but it sure did. Okay, I think it's in focus. Okay, again. We had a parabolic path from 12.5 to 0.2. Okay. could say h of x equals. Okay, I've got myself in trouble. I've got to figure out the equation for this parabola. I think its vertex is going to be about here. And that would be at about 0.78. Okay, so start at 12.5, go up to vertex at 7.8. So now I can write down what my equation would be. It would be y equals a times x minus 7 squared plus 8. Or y equals 12 when x equals 5. So we have the equation 12 equals a times 5 minus 7 quantity squared plus 8, which equals 4a plus 8. Well, we solve that for a, we get a equals 1. I'm not going to write out the details, but it's pretty easy. Solve equation 12 equals 4a plus 8. And we do get a equals 1. So h of x turns out then to be wrong. A has to be negative. So we've got a problem with that. Must be a problem with my physics. Oh, the problem is with my numbers. Don't do this like I did. Y wasn't equal to 12 here. Y was equal to 5 when x equals 12. Okay. So this is much better. Now, if we square 12 minus 7, we get 25. Here we get 5. A turned out to be negative 3 over 25. Okay. And negative 3 over 25 is what, 1, 2, I don't know, I'm going to put a 0 there. And then we have x minus 7 squared plus 8. Okay. So notice I did a really careless thing here when I wrote down the x and the y coordinates, and then I went on with it. Didn't use good common sense. And I really did that. Be careful yourself. And the main thing to take away from that is what I got didn't make sense. I could see immediately it didn't make sense. So I went back and fixed it. And I have to do that with some problems too. Try not to make mistakes in the first place. Okay, so we have h of x is 0.12 times x minus 7 squared plus 8. Now, X equals 0, is H really equal to 2 like I said it was? Go ahead and check that out. If X equals 0, then you're gonna substitute 0 for X here. Some people have a lot of trouble understanding what that means. It means you write down you replace X by 0. You take this whole equation, this whole definition, and replace X by 0, just as you do if you're doing a composite function, but this isn't a composite. You do this, and then you evaluate this. Okay, well, if I do that, I find that if X equals 0, H equals negative 2.5. Y equals 2.5, not negative 2.5, not negative 2. Now, what does this mean? This means that if I calculated the model like this, I would have missed. Okay? So I didn't calculate my model this way. Obviously, I calculated my model correctly because I didn't miss. Okay? And since I never missed, that was right. Okay. Um, this isn't a good model. Since I didn't miss, I obviously was thinking about a different model. Now, my question is, I've really used this model how far short would I have been? That is where the chunk have been when y equals 2. Because it was supposed to be at 0 when y equals negative, when y equals 2, right? But according to this model, it was already 2.5 feet below the floor. 4.5 feet lower than this when y equals 2. And I said, they're drawn very well to scale, which is another reason why this model didn't work real well. But there we have it. Okay, so what we do is y equals 2, we're going to find x. So y equals negative 0.12 times x minus 7 squared plus 8. If y equals 2, we get this. How am I going to solve this equation? Well, to solve this equation, I'm going to subtract 8 from both sides. Subtracting 8 from both sides, I get negative 6 equals negative 0.12 times x minus 7 squared. I'll write this up here. Negative 6 equals negative 0.12 times x minus 7 squared. I'm going to divide both sides by negative 0.12. And that's going to give me x minus 7 squared equals 50, approximately. Solve that. X minus 7 is plus or minus the square root of 50. And things get narrow here. I'm going to have to come down a little further. We get x approximately negative 14, or x approximately equals 0.1. And that doesn't seem to agree with much of anything, but that's how we would answer it. There's something wrong with this because we figured out, uh-oh, I know what it is. We should have let you do the arithmetic here because I messed it up. This tells me that it should hit 2 when x equals 0.1, okay? Well, over here I did ignorant arithmetic. At one point, I multiplied the 0.12 by 7, got 8.4 because it's 12 times 7 is 84. And I used that instead of 49 when I squared 0 minus 7. So really, this was the correct model. Over here, this should have been pretty much -6. It would have been -5.9, which would give me positive 2.1. So why should it should have been very close to 2 when I got here? So this was a good model. Okay, well, interpretation aside and arithmetic error aside, this illustrates a lot about how you can use a quadratic function in an application. So that's the homework assignment for next time. And I see some people have already started that assignment. That's good. I like to see good proactive work, and looks like everybody got a good start who did that.